I will discuss the time-shifting property of Laplace transform. First, let's discuss some basic concepts of the time-shifting property. If the Laplace transform of f of t is f of s, then the Laplace transform of f of t minus a is e raised to negative as f of s. By definition of Laplace transform, the Laplace transform of any function is the integration from 0 to infinity of the function and e raised to negative st dt. Substitute u, which is equal to t minus a, and t, which is equal to u plus a, and by differentiating on both sides, dt will become du. Since a is a constant, the differentiation of a is 0. By replacing t minus a by u, t by u plus a, and dt by du, our equation is now the integration of from 0 to infinity f of u e raised to negative s quantity u plus a du. By using the property a raised to m plus n, which is equal to a raised to m times a raised to n, we can write e raised to negative s quantity u plus a into e raised to negative s u times e raised to negative s a. Since e raised to negative sa is a constant, we can take it outside. Our equation will now be e raised to negative as integration from 0 to infinity f of u e raised to negative su du. By the definition of Laplace transform, the Laplace transform of f of t minus a is equal to e raised to negative as f of s. For our sample problem, we will find the Laplace of combination of impulse functions. Find the Laplace transform of delta t of t plus 1 plus delta of t minus 1 plus delta of t minus 2. We know that the Laplace transform of delta t is 1. Therefore, we can assume that the Laplace transform of delta of t minus t sub o is e raised to negative s t sub o. Individually, you can calculate the Laplace transform of each function, then add because Laplace transform allows linearity property. The Laplace transform of delta t plus 1 is, if we compare it to the property, they have unlike signs. Therefore, the sign of t sub o will become negative. By following the same procedure, the Laplace transform of delta t minus 1 when compared to the property, they have like signs. Therefore, the sign of t sub o is positive. Same goes for the Laplace transform of delta t minus 2. They have like signs, therefore it is also positive. Hence, the Laplace transform of our given is e raised to s plus e raised to negative s plus e raised to negative 2s. This is only the bilateral Laplace transform of our function. Sometimes, they will ask for the unilateral Laplace transform. The unilateral Laplace transform only covers values between 0 and infinity. Whatever the values of t that is between 0 and infinity will only be considered. To get the value of t, equate t to 0 to get the time period. By equating t plus 1, t is equal to negative 1. By equating t minus 1, t is equal to 1. By equating t minus 2, t is equal to 2. The path of the signal which are in the range of 0 and infinity, t plus 1 is not included because it is a left-sided signal. Therefore, the unilateral Laplace transform of our given is e raised to negative s plus e raised to negative 2s.